Let's talk about solving linear systems using matrices. Our objective, we want to solve a linear system using an augmented matrix and our TI calculator's Reduced Row Echelon Form operation. Reduced Row Echelon Form is abbreviated rref. So we want the calculator to do all the work for us, and it will gratefully do that. So what do we know that we want to remember? We know that when we solved a linear system in two unknowns, we used the addition method, the substitution method, and back solving. We also learned how to do it with graphing, but I want to focus on these two things. I'll focus on these two for this objective. We know what an augmented matrix is. It is a shortened way of writing a system of linear equations. We have a vertical line that separates our columns into two groups, a right side group and a left side group. The coefficients of our variables are placed to the left of the vertical line in alphabetical order. So in this case, we have X, Y, Z. So these are the X variables in column 1, the Y variables in column 2, and the Z variables in column 3. If you want to, I'll go ahead and write that above. And our constants are placed to the right of the vertical line, 31, 19, 25, to the right of the vertical line. So those are our constants, which I'll label with the number symbol. We also know that a matrix has a size. It's called its order, and it's indicated by row column. So these two augmented matrices have size 3 by 4, 3 rows and 4 columns. We need to know that for our calculator. So at the bottom down here, the TI calculator's Reduced Row Echelon Form, that operation basically uses the substitution method and the addition method and back solving for us. Okay, it does the math behind the scenes and all the software, and then it pops out the answer to a system of linear equations. Absolutely awesome. How do we do this? In general, we're going to create the augmented matrix. We're going to use our matrix functionality and our edit button for some of this. There's also a shortcut button in some of the TIs. And then we're going to use that rref, Reduced Row Echelon Form operation, to solve it. And that is under the matrix umbrella. Under math, you will find rref. Let's take a look. I'll do these in a couple of different ways because there are various versions of TI calculators out there. I'll try to cover a couple of those versions as I do this. Certainly, the newer the TI calculator you have, the easier this is. So, example 1, we're going to start with a two equation and two unknown example that we've already done in a previous video. So here's our linear system. 3x plus 2y equals 48. 9x minus 8y equals negative 24. We did this example before. We discovered that these two lines intersect, which means the solution is consistent. And we discovered that their intersection occurs at the point 8, 12. All right, so let's do this as a augmented matrix. So we're already set. They each have an x, a y, and a constant. So let's create our augmented matrix. And we'll have 3, the coefficients, 3, 2, and then we have our line, and then the number is on the right side. This is my x column, this is my y column, and this is my number column. So this is my first equation in the augmented matrix. My second equation will have 9, negative 8, and negative 24. 9 and negative 8 are the coefficients. They go to the left of the line. And negative 24 is our constant. it goes to the right of the line. All right, so what we want to do is we want to rref. We want to reduce row echelon form operation this thing. And I'm going to do this a quick way. So we want to take rref. We want to build our matrix in our calculator. Now our calculator doesn't have a vertical line, so I am simply going to kind of indicate that with a dashed line so we kind of keep it separate just to kind of help us visually, but it is not, this vertical line is not in our calculator. So we want to simply reduce row echelon form the matrix like this. And what's going to happen? Let's take a look. I'm going to do this a shortcut way with my TI-84 plus CE, and then I'll do it a little longer way for those who don't have this functionality. Here we go. Turn it on. Now, in my calculator, well, in all calculators, we have a matrix. So here's a matrix. The matrix functionality is right here. It is a blue key. So I need to press second and then matrix. And up come these three options: names, math, and edit. Math is where all the mathematics takes place, as you might imagine. I'll go to math, and I can scroll up or down. I'll go down this time because it goes to lots of stuff that we're not concerned with. We want to find letter B on my calculator, which says rref. And we want to enter that because we want to reduce row echelon form a matrix. Okay, on my calculator, I have a shortcut key to build a matrix. It is an F3 key, which is green. So I'll press alpha F3, and I can build my matrix right here. And here's where it's important to notice that this is a 2-row by 3-column matrix. Okay, again, 2 is the rows, and 3 is the columns, row followed by column. And so I need to select 2 in the row column and 3 in the column. 3 in the columns column, yes. So I'll go up here with my cursor and I'll press enter to get 2 rows. I'll go to the right. I'll come down to 3. I'll press enter. So I'm telling my calculator, please give me a 2 by 3 matrix. Come on down to OK and press enter. And there we have it. Now I just need to fill in the data. Again, notice there is no vertical line. We just enter 3, and I just go across the top with the right arrow key. 3 followed by 2, followed by 48, and then it goes down to the second row, which is 9, -8, and -24. I go out of that, I close the parenthesis, and I press enter. And here's what comes out, the answer. So this comes out and it says 1080112. Now I'm going to go ahead and put that dashed line down there, and this tells us the answer. We know that this column is the x's and this column is the y's. So if I read it, I have 1x plus 0y's is equal to 8. What does that mean? X equals 8. 1x and 0y's. I have 0 x's and I have 1y equals 12. And what does that mean? Well, that means that y equals 12. So the answer is the ordered pair 8, 12, but we knew that right there. Okay, so that is the TI-84 shortcut way. Nice way to do it. You can put rref in first, build your matrix from the shortcut alpha F3, enter your numbers, and then press enter, and life is good. Let's do it a little longer way for those who don't have a TI-84 or don't have that shortcut. I'm going to go into matrix, and I need to edit a matrix, okay? Currently, my matrix A is a 2 by 3, which is what I have here. This is 2 by 3, but it might not be the right one. I'm highlighting matrix A. I'm going to press enter. If I need to adjust the row and the column, I can put in like a 3 by 4, for example, but I don't need to. there's a 3 by 4. Okay, I'm going to go back and make this a 2 by 3. And as I press the right arrow, you can see, I'll get a little straighter here. You can see I've created a 2 by 3 matrix. Okay, well, looks like I was kind of doing this problem. 3, right arrow, whoops, 3, enter, 2, enter. That number should be 48. Looks like I had a 24 in here. So press 48, then press enter. 9, enter, -8, enter, and then -24, enter. And there you have it. I have now built the matrix. It is matrix A, like this. So I'm going to go out of matrix. So go second, quit. And I'm going to go back into matrix, second, matrix. Now I'm going to do some math on it. So I go to math. And then I'm going to scroll up this time until I find rref, up or down, either works. I want to I want to use the operation row reduced echelon form on the matrix I just created, which was matrix A. So I go back to matrix. Here it is under the names. It was matrix A that I edited. So here it is. I'll choose it and I'll close with parentheses. So I had to create the matrix, had to edit the matrix, and I edited matrix A. And then I had to go back into matrices and rref, and then select A from the names column, and you'll see I get the exact same answer. A little longer, but certainly easier than using the addition method or the substitution method or the graphing method. This is fairly quick. Okay, let's take a look at a 3 by 3. All right, I think I'm good. Solve the system. All right, I think I got my paper straight. I'm never sure sometimes, hard to tell. Okay, so I'm going to use this as a system. This is a linear system of 3 variables. So I have three equations and 3 unknowns, and I want to use the rref operation. I don't want to go through that whole process I went through in a previous video. That was a pain. So let's first write it as an augmented matrix, which means I need to have all of my variables accounted for with zeros as necessary. And so I have my first equation will be coefficients 0, 2, -1, and then I'll draw a line, and the constant is a 7. And then my second equation has coefficients 1, 2, 1, and constant 17. My third equation has coefficients 2, -3, 2, and constant -1. Again, let's recognize this is my X column, this is my Y column, this is my Z column, and let's also recognize that this is a 3 by 4 matrix. All right, so we want to rref, we want to reduce row echelon form this matrix, and I'm going to rewrite it again, only this time I'm going to include a dashed line because there's not a solid line, and it just helps me to see it visually. So 1, 2, 1, and then put a 17, and then 2, -3, 2, and a -1. All right, I'm going to do this again 2 different ways. So I'll put my calculator out here. I'll do it my shortcut way, and then a long cut, as my father would say, taking a long cut. We'll do a longer way. So back here, okay, my shortcut way says I can first go to the matrix menu. I can go to math. I can go to rref, press enter, and then I can use alpha or green F3 to pull up with the size of the matrix I want. Well, this time I want a 3 by 4, so I'll go up to the row column and choose 3. I'll go to the column and choose 4. I'll come down to OK, and it says, here you go, Coleman. Here is a 3 by 4 matrix for you to fill in your data. And my data I can just barely see here, 0, 2, -1, 7. So 0, 2, -1, and 7 is row 1. Row 2 is 1, 2, 1, 17. 1, 2, 1, 17. And row 3 is 2, negative 3, 2, and then negative 1. I'll come out, I'll close the parenthesis because I have an open parenthesis here, and I'll press enter. And here's what comes out. Okay, I've got 1, 0, 0 with a 4. And again, I'm going to put that dotted line to help me visually see what's happening. And then I've got 0, 1, 0 with a 5. And then I've got 0, 0, 1 with a 3. Let's remind ourselves, this is the X column, this is the Y column, and this is the Z column. So what does this tell me? Let's move this out of the way. This tells me I have 1X plus 0Ys plus 0Zs equals 4. Well, that means that X equals 4. The second row, tells I have 0X's plus 1Y plus 0Z's is equal to 5. Well, that means Y is equal to 5. And then finally, the third row, 0X's plus 0Y's plus 1Z is equal to 3. So that means that Z is equal to 3. And so I have a solution. It's an ordered triple. X is 4, Y is 5, Z is 3. Okay, let's do that again. This time with a little longer method for those who don't have the shortcut like I do. Okay, so go back into Matrix. And again, I need to edit my matrix so that I need to create a 3x4 and then put in my data. So I'm going to go to edit, and I'm going to edit matrix A. I don't need it anymore. And first I'm going to enter my row column. So 3, 4, and it sets me up. Okay, I now have a 3 row by 4 column matrix to fill in. 0, 2, negative 1, 7. So 0, enter, 2, enter, negative 1, enter, and 7, enter. That's my first row. 1, enter, 2, enter, 1, enter, 17, enter. That's the second row. The third row is 2, negative 3, 2, negative 1. Oops, I didn't get the 1 in there. There it goes. I just put a negative in. I forgot the 1. There we go. So my matrix has been built. So now I have to go, it's matrix A. So now I have to go rref, matrix A. So I'll get out of matrices. I'll go back into matrices and I'll go to math. And I'll scroll up or I'll scroll down until I hit EF. I'll press enter. It's looking for what matrix, so I'll go back into matrix. Its matrix A was the matrix I just created, so I'll choose A. So now it says you want me to use my reduced row echelon form operation on matrix A, and the answer is yes. I'll press enter, and you'll see the exact same solution in both cases. This one just took a little longer because I have a nice shortcut button on this TI-84 Plus that I have here. So there you have it. How much nicer is that than it is doing that page and a half of work that I did in a previous video? Let's look at one more example, kind of an application example. So give me a moment while I get my paper together. And I'll probably just do this one with my shortcut. I'll let you, my shortcut matrix one a little quicker. I think I'm straight or reasonably straight. Okay. All right. At a college production of Clue, the play Clue, 400 tickets were sold. The ticket prices were $8, $10, and $12, and the total income from the ticket sales was $3,700. How many of each type of ticket were sold if the combined number of $8 tickets and $10 tickets sold was 7 times the number of $12 tickets sold? Oh my goodness, a lot going on here. What matters first is we define our unknowns. So X is going to equal the number of $8 tickets, and I'll abbreviate tickets TIX. Y is going to equal the number of $10 tickets, and Z is going to equal the number of $12 tickets. Okay, so if I look at this, I have 3 unknowns, and that means we need 3 equations to solve it. Yeah, if I've got 3 unknowns, I need 3 equations. Okay, so we're setting ourselves up for a system of linear equations in 3 unknowns. So let's set that up with some curly brackets. Well, what do we first know? 400 tickets were sold, okay, which means the number of $8 tickets plus the number of $12 tickets plus the number of $10 tickets plus the number of $12 tickets is 400. So our first equation, X plus Y plus Z, is equal to 400. Okay? Second equation, the total income was $3,700. Well, every $8 ticket cost $8. Go figure. So 8 times the number of tickets in the $8 pile, 8, plus 10 times the number of $10 tickets, plus 12 times the number of $12 tickets, gives us a total income of $3,700. That's our second equation. Again, reading from the problem. Okay, we also were told the combined number of $8 and $10 tickets sold was 7 times the $12. So the number of $8 combined with the number of, the number of $8 tickets sold is X, combined with the number of $10 tickets sold, which is Y, equals 7 times the number of $12 tickets sold, which is 7 times Z. So there we have our 3 equations and 3 unknowns, and we're good except for one thing. This one's in general form, this one's in general form, this one is not. So let's put all 3 in general form. The first equation is already there. The second equation is already there. The third equation, I need to subtract 7z from both sides. So x plus y minus 7z, and I'm left with a 0 on the right side. The 0 is the number, not a problem. Now I have my 3 equations in the general form. All variables are accounted for with a coefficient. Let's create a matrix and row reduce echelon form it, although it's not a verb, but let's just do the ref. And I'll put it in. This is a 1, 1, 1. And again, I'll use a dotted line, and I'll come up 400 on the right side of that dotted line. This is an 8. The second equation has coefficients 8, 10, and 12, and a constant term of 3,700. My third equation has coefficients 1, 1, and -7, and a constant of 0. That can go in. All right, so let's go ahead and, again, I'll do this one time with my shortcut. Let's see here. So I gotta make sure I've got myself set. So I'm gonna go back into matrix, and I'm gonna do my math, my row reduced echelon form, and I'm gonna use my shortcut to create, this is a 3 by 4, let's make sure. Yep, this is 3 rows by 4 columns. So I'm already pretty good here. I've already got my 3 by 4 set, so I'll press enter. Let's put in my numbers. 1, 1, 1, 400, 8, 10, 12, 3,700, 1, 1, negative 7, and 0. Close the parenthesis, and out comes. All right, so out comes what I was hoping for, a 1, 0, 0. And again, always a dotted line, 200. So x equals 200. A 0, 1, 0, 150. So y equals 150. Remember, these are x, y, z columns. And then a 0, 0, 1, 50. So z is equal to 50. Let me close off that for us. So what do we have? We have 200 $8 tickets, because X was the number of $8 tickets. We have 150 $10 tickets, and we have 50 $12 tickets to solve this problem. So there you go. Aren't they nice? They work really well. Get used to using your matrix and that RREF button.